Thank you, Christian, and good morning, Snowflake Summit. It's great to be here. So let me start with a question. Why is it so hard to build continuous data pipelines with reliable execution guarantees? Well, one of the reasons is you have to pick a messaging system. You have to connect your messaging system to your data sources. You have to configure that messaging system to load data into Snowflake. But also you have to write your business logic, run it 24/7, and manage the compute resources that do that. For the purpose of this demo, I've chosen an IoT scenario to illustrate how easy that gets with the new data pipeline features that Christian just introduced. For this summit, we have custom built a number of IoT devices. They look like that. They're built on the Particle Argon platform. They're connected to the internet. And they're tracking activity like movement when I'm moving it around, motion, velocity, also orientation and temperature. So what Christian is saying, take a look at your watches. That will be useful in a couple of minutes. So as I mentioned, the device that you see here is connected to the internet, and we have built a complete end-to-end data pipeline behind this device. Let me show you the pipeline first. So the data is being sent first into a Kafka topic. We're listening on that Kafka topic and loading data continuously into a staging table in Snowflake. As soon as new data arrives there, we're picking it up, transforming it, and sending it into a target table that has the right shape for our dashboards and our analytics. So what I would like to do is to take you through the steps that we have taken to build out this end-to-end demo and show you parts of the demo along the way. So let's move over here. What we're looking at right now is the first piece of the pipeline. It's Kafka. We're connected to the Kafka console, and we're listening to the topic that's consuming the events from the device that you just saw. For a real-world scenario at scale, we'll probably expect to have hundreds, thousands, or millions of devices sending their data into this topic. In this case, it's just one device, the single device that I just held up. You can also see that the data is being rendered in JSON, which is nice. And we obviously would like to load the data into Snowflake now to run queries and analytics over it. Now, with the new Snowflake connector for Kafka, this gets really easy. You install the connector by installing a jar into your Kafka Connect cluster. And this is where you run it. We are hosting and running our own Kafka cluster in the AWS EC2. And let me show you the Snowflake Kafka connector configuration so that you get a sense of what it takes to set this up. It's fairly straightforward. It's just a couple of lines. Probably the most interesting piece is what's the set of topics that you are listening to on the Kafka side. And you can see here we're listening to a topic that's called activity raw. The next couple of parameters define what Snowflake account you're connecting with. And then here are a few other parameters that specify the target location for the data from the Kafka topic. And by default, the Kafka connector is using a table name that is the same name as a topic, as its target, which takes us over into the Snowflake side. So here I just switched over into the Snowflake web UI, and we're looking at the staging table here. And notice that it has the same name as the Kafka topic that we're listening to. You can also see we are using the familiar variant data type to store the JSON that we're receiving from the events from the device. Now, we could stop at this point and just define a relational view over that table, promote out the properties from the JSON that we are interested in, and then run our analytics or queries over it. But as Christian mentioned, a lot of you have given us feedback that this is too simplistic. You need to run merge statements, or you have multi-statement transactions that need to maintain multiple downstream tables from your staging table. So to reflect these more complex business scenarios, I defined this additional table here that you see, which has a couple of columns to represent properties from the device data that we are receiving. So the objective now for us in the demo is to consume incrementally from the staging table new data as it arrives, transform it into the shape of the target table, and then write those transformed rows into the target table. We obviously want to do that in a highly reliable fashion with exactly once guarantees. For those of you who have worked in that space, you know how incredibly hard that is to implement and get right. So with the new capabilities for table streams and tasks, this gets a lot easier. Let me show you how. So real estate here. So the first step that you take is to create an actual stream over your staging table. And that's those two lines that you see here. That gives you the ability, as Christian mentioned, to incrementally consume changes from the staging table through the stream with transactional guarantees. Once you have defined your stream, the next step is to define a task. And here you can see a task that defines our business logic. Let me take you through that task definition step by step. The first clause that you see here is the warehouse clause. It defines where your processing runs. In this case, it's a user warehouse called Snowflake tasks. The next clause is the schedule clause, and it defines when your processing runs. Here you can see it runs every minute. You can also provide a cron definition for more complex schedules. Then comes the body of the task, which is the business logic that you want to run on that schedule. And you can see here, we're inserting into our target table the projection list in the select clause does the JSON parsing and the calculations that we want to do over the data. The from clause incrementally pulls the changes from the stream, from the staging table, whenever the task wakes up. And then the where clause illustrates how you can use a metadata column on the stream to make sure that you're only acting on actual insertions into the staging table. Once you have put these pieces for your pipeline together, you kick off the processing for your pipeline by calling an alter task resume statement. Once you have your pipelines running, you can switch over into the history view in the Snowflake Web UI. And we've added a new checkbox that you see here that allows you to include the queries that are executed by user tasks. And when I refreshed this a little earlier today, you can see we had that task running about once every minute, which is exactly the schedule that we wanted. So let me take you over into a Looker report that you can see here. And the Looker report pulls data from the target table that we have been populating with that stream and with that task. And as you can see, the first chart plots the device activity, and you can see it's been very, very quiet for quite some time. And suddenly there's a spike in activity, which was me holding up the device and waving it at you. And it shows in this chart here. You can also see the orientation of the device. As I was picking it up and turning it around, the orientation of the device changed, and you can see that reflected in the chart here. Also, you can see, it's quite interesting, the last timestamp that we have received from the device. If you compare that to the current wall clock time on your wristwatches, you'll see that we're just a couple of minutes behind wall clock time, which is exactly what we want. So with that, I hope you got a sense of what you can accomplish with these new capabilities. The key three features that we talked about in this demo is the new Kafka connector for Snowflake. It allows you to load data from a Kafka topic directly into a Snowflake table. The second one is the new table streams. It allows you to consume changes incrementally from a table in Snowflake with reliable exactly once guarantees. The third one is scheduled tasks. Scheduled tasks allow you to schedule and run business logic completely inside Snowflake without having to worry about managing compute resources anywhere else. I very much look forward to the data pipelines that you are building with these new capabilities. Thank you very much, and have a wonderful summit.